Okay, somehow the software kicked me out. I don't know why, but hope you all can join again. Okay, you are coming in the class now. So somehow the software kicked me out. I don't know why, but so let's wait for a second. So all of you are requested to join this session. Okay, thank you very much. And I'm really sorry for inconvenience. So we have two options. One is to minimize the variance, portfolio variance, and the other one is to maximize the return. We are considering how to minimize. We are considering how to minimize the variance. So we have this equation. So we need to minimize this one because we know that this one is the VP, right? We know that from here. So we need to minimize this variance with subject to the weights. What are the weights? Weights are to allocate the investment in proper portfolio. So could you please ask other students to join this session? Because I think somehow only 22 students or 21 students can join. Rest aren't joining it. Now we have here one assumption. We already deal with this assumption. And what is this assumption? This assumption is that we're gonna invest all of our wealth.
这时候就体现了 iPad 玩游戏的好处。
100%, and we're gonna invest students
别帮我清兵了。
join.
好的。
有人没关麦啊？
Actually, something happened. There was some problem in the. It just kicked me out from this class, so I have to make another class. So we know this condition. It means that I'm investing all of my money into portfolio, into stocks. So otherwise, if I don't do this, and I keep one portion, let's say this is W1, W2, I invest my all money into 10 stocks, right? So instead of all money, I don't do this. So I keep something with myself, and rest I invest. So it means to the 10th stock, the weight will be 0. I'm not investing into the 10th stock. So that can create a problem. So this can lead a VP is 0, because if one stock is having 0 investment, it can give us the whole portfolio as a 0 variance. So it can mislead the information. That's why we always say that we need to invest all of our money, right? So in this case, we can write this, because sum of W, we can write transpose 1n equal to 1. Now we need to solve it. We need to solve W with the minimum variance portfolio. What is MVP? Minimum variance portfolio. So we invest such allocation, or we allocate such an investment which minimize this variance. What is that? This is the formula for that. This is one matrix with n numbers, right? Times 100%. This means 100% wealth, because sum of W is 1. V inverse, this is given 1 by n. V inverse 1 transpose by n. So that's how we can calculate each weight. How we will better see into the, we will better see in the Excel form. But remember, this is another way. This now we got the weight for minimizing the variance portfolio. That's the formula for finding the weight while minimizing the variance. So if your variance is given, then you can calculate this one by calculating it. Now you know how to calculate inverse. So V inverse will be 1 upon V determinant and then adjoint of V. That's the inverse formula, right? How to get adjoint, you already know that, right? We discussed this in our last. So someone cannot see the board clearly. Can you see the board now clearly? So we have another formula, which is WMVP. MVP means minimizing variance portfolio. That weight is 1n because sum of W is 1. We are investing all of our wealth upon 1n. V inverse 1 transpose of n. So 1 shows the whole wealth. That's one thing. Now we talk about the, it is also, now we talk about the portfolio. This one is also known as Markovic portfolio. Let's see, what is this? Oh, sorry, literally sorry. Okay, so I didn't have like thought about that thing. So okay, I repeat. So this one, because sum of W is 1, we are investing all of our wealth, right? So it gives us the transpose and the weight W is 1n matrix, like n times 1. Every stock has, all the stock have like 1 total wealth, 100% wealth. So we can write W MVP equal to this. We know this is this. So VP is this, right? So from here you can get W. So see, take the W here and take this VP there, V there, and it will give us into inverse. So we just change the positions here. So once V goes there, it becomes inverse, right? V inverse, and this one, this W, because this is a whole investment. So whole investment is 1, right? So I can write this one as 1n V inverse 1 transpose n. So 1 is W because it's the whole sum of W, right? Sum of weight is the whole investment. So I can write this one into this formula. Same thing. I can derive this W from this one. Yes, I can, right? So take this V there, when it will go there, it will change into inverse, and take that V here, it will also get into inverse. Okay, so now let's see how to select the optimal weights. So we have equation minimize and constraint. What is the constraint? That we are investing whole of our investment. That's the constraint. And we have second constraint, that weight ERP is total return, right? This one, the return on portfolio. So these are the two constraints to minimize this. And when we solve it, we can find the optimum weight. This one is known as, when we have this equation subject to these two constraints, we call it Markovic portfolio allocation. We will see this in an example. So here we can use the matrices for all these, and we can find out the Markovic portfolio allocation. So remember this one. Now we can use how to get the weight, the same weight, by maximizing the return. So this one is about minimizing the variance. If you are getting a little bit confused, don't worry. When we will come to the Excel example, it will we get more clarification. This is analytical part, so it may give you some question mark, but you can see, you can revise it at home and you will know what I'm talking about. So we can also get the same equation by maximizing the return, right? So when we maximizing the return, so we have this equation. Now we need to maximize the return. So what is the return equation? W prime ER minus RF. So return on portfolio minus expected return divided by this is equations. So what is the subject? Subject is that we invest all of our money. That's the subject line. So we have weight here, transpose of weight, we have expected return, we have RF, return on one stock or any stock F, and we have this variance, covariance matrix. So everything is given. So now it's easy. So if we derive like first order condition, and we will get the optimum weight as this in this formula kind of form. I'm not going into the proof of this at the moment, but later on, if you want some questions, or if you really want to have a proof, because it's more mathematically, we can do that during the Wednesday on my office timing. So all these things are given, then you can easily get weight. So let's see how to do this in Excel. Now from here, you need to remember these two things: this one, this one, this one, and this one. Now I will take you away from the whiteboard, and I will take you to the Excel. Okay, so let's move to the screen sharing. Yeah. First, we need to collect data. How to collect data? That's the problem. And from where? Oops. So you can open Bing, Baidu, Google, anywhere. And you can, because Yahoo is easily accessible from China as well. So if you have your laptops with you, you can open your laptop and you can follow me as you see on the screen. Okay. Joe, can you send me a picture? What can you see on the screen? somehow it got muted. So now you can hear me, right? Sorry, somehow it got muted. I don't know, maybe there is some button clicked. Can you hear me now? Oops. Now you can hear me, right? So anyway, I was showing you how to extract the data. So now I got the data for Nike, I got the data for Adidas, I got the data for Puma. So I have already arranged the file, and that's the file. So I have collected the data. See, this is N, this is A for Adidas, P for Puma. Now I need to calculate the returns. Simple way to calculate the return. So this is the return of Nike. What you can do, you can say put equals, then you have to use current divided by previous value minus 1. That will give you a return. It can also give you in such a way, like look, then you have to change. I don't know how much Excel you are good at, but it's really good, useful. So that's why I'm gonna make a simple. So this is the return on Nike. So when I do this, I will just take current divided by previous minus 1. So it gives me minus 0.0889. So I select this number and I put it percentage. So when I put it percentage, it gives me a percent. Then I put 2 decimals, and I'm gonna drag this until here. So this one is because there is no previous value, so I don't need this. So I'm just gonna discard it. Then what you can do, you can select it, and after select it, you see you put the cursor on the corner, and when it gives you this plus sign, just click and drag to 2 more, because I have to use the same formula. So I'm gonna this. So now I got the returns. So this is return on Adidas stock. This is return on Puma stock. See, if you don't wanna, you wanna confirm that, see, it's an Adidas. So that's how. So I have already done this. So I have this thing. Now I need to do portfolio investment. So for portfolio investment, I need to give weights. So let's say this is W1, W2, because I have 3 stocks, so I'm gonna put weight, and sum of W should be 1, or it should be 100% wealth. So that's my goal. So what I do, I just give like let me copy here. Okay, you can hear me now. That's good. So let's say I put a weight here, 0.33, just random. It should be equal 0.34. It should be equal to 1. So I just give it to make it easy. That's why I just give 33, 33, and 34. You can give it like 10, 10, 80, right? It depends on you. So it should be 1. Now, what is the return on portfolio? So RP, simple, equal Nike return and the money I invested in Nike. This one plus return on Adidas and the money I have invested on Adidas. It's a plus sign. And plus Puma and the return, the weight I have allocated to Puma stock. Now remember, the return, the weights are fixed. So if you put F4 button, F4 from your keyboard, it changed into, it added dollar sign. So dollar sign means you fix this number from column and rows. So if rows and column changes, this number is still there, right? So I need the same number because these weights are not changing. So I will put F4 to every weight, and then I will put enter. return on portfolio. So let's see its portfolio so that it doesn't get confused. So this one I get. So change it into percentage. So it gave me 0.57 portfolio invest if I invest in these three stocks with who are giving me this return. Understand? Now I will change again when the plus sign is there, I will drag it to down up to here. Now I got the return on portfolio. What I need to do, I need to get the variance of portfolio. That's on each with different weights on each investment, right? So what I can do now, I have to calculate the mean, variance, covariance, correlation. So what is this? Can I write here or maybe here? What is mean? Average. So I can use average formula here and put the Nike here. So that's for the Nike. That's for Adidas. That's for Puma. That's for portfolio. All right. So look, it gives me in percentage. So average return on Nike is minus 2.17. This means I'm losing money. So if the plus sign is there, because we're gonna use the same formula for 3 of rest, so I'm just gonna drag it. So it give me this one. Now you can recheck your this portfolio. How? Because you remember you have given the weight, this one. So you can add Nike times this much weight, because what we have invested in Nike, plus Adidas times this much weight, plus Puma times 0.3. So it will give us the same results. See, if I change into percentage, so you see these two are similar. So that's two different ways you can get the mean. Now let's talk about the variance, how to calculate the variance. So for variance, we have simple formula. We're gonna use VARP, and then we're gonna select Nike, and we're gonna select all these entries, return, and this is the variance on Nike. So this is the variation between, we are not writing into percentage because it has a unit, that's why. So this is the variance, this is the mean on the stock return. Mean on the stock return of Nike, mean on the stock return, not on the stock. This is not the stock mean, this is the stock return mean. So mean, if I get the mean here, then this is the stock mean. But I'm taking the mean on return, so this is the stock return and variance return. Understand? So because I'm gonna do the same thing here, so I'm just dragging the formula up to here, not the last one, because portfolio variance will be different, because now we have a different formula to calculate the variance for portfolio, not this one. So, and standard deviation, you can take the square root of variance, SQRT, or you can use the standard deviation formula, standard deviation VP. Same this one, right? So that's the standard deviation. Covariance, we don't know yet, we were gonna do it, but first let's finish this one. So there's a covariance. Now what is the covariance? For covariance, you can simply get the formula COVAR. Yeah, it gives us the covariance, return covariance. So 2. So covariance is a relation between two stocks. So let's say first relation between Nike and Adidas. Right? So this is Nike. and this is Adidas. So I have selected these two. So this is the covariance between Nike and Adidas. This is the covariance between Adidas and Puma, and this is the covariance between Nike and Puma. Because it's symmetric, so it doesn't matter which one I write it first. So these are the covariances of these three, because we have three assets, so we just calculate like three. Correlation. Similarly, just like covariance, you can get the correlation between two variables. This is between Adidas and Nike. Correlation. This is between Adidas and Puma. And this is correlation between Nike and Puma. So what does this shows? This covariance between Nike and Adidas shows that if there is an increase in Nike, the Adidas will also increase. So all these shoes stocks, they are linked to each other. They have a relation to each other. So if one increases, the other one will increase. Right? Now we have this one. Now we have to make a covariance variance matrix. Variance, covariance matrix. Simple. How to calculate this? We know that variances are on the diagonal, so I just paste it as values, because otherwise the above one is the formula. So paste as value. This one comes here, and this one comes here. So here, this is now the covariance between Adidas, Nike and Adidas. So Nike and Adidas, this one is the covariance, right? Paste value. This one is Nike, Adidas and Puma. So this is 1, 2, and this is 1, 3. So this is between Nike and Puma. So this is Nike and Adidas. This is gonna be Nike and Puma. And this is gonna be 2, 3 is gonna be Nike and Adidas and Puma. So I'm just gonna use paste values. So because it's symmetric, so I can use this into transpose here. Paste special, paste transpose, and this as it is here. So this is my variance covariance matrix for this. All right, so this is my covariance variance matrix. So on the diagonal, I have variances, and the rest are the covariances. Right, I have done this here already. Now let's find out the variance and standard deviation of portfolio. So you need to add up the formula. And what is the formula? Remember, you have weight. Oops, where is this? So here I'm gonna get the portfolio variance. So you can also get like VAR, P, and what is the portfolio here? This is simple, and you can enter. Oops, why, it's like this. Equal VARP, and then we have to do portfolio and select all the portfolio returns and take the variance, and you get this 0.338. This is the portfolio variance. Now there is another another way to get the portfolio variance. It is similar, not equal. So how I can do? We can do mult. Then I have to select the weight. So here I have to select the weight, which are these. Then wait, where is the marker? So it's mult, then transpose of weight, because we know that it's W transpose from the formula which we have written on the board, remember? And then mult, and then variance covariance matrix, and then W. That's the formula, right? So if we put here mult, so first transpose of weight, so I can further input another transpose formula, and weight is here. So this is the transpose vector, then comma, then again mult mult, and now variance covariance matrix. Where is my variance covariance matrix? This is my variance covariance matrix, right? And then comma, and then the weight matrix itself. And then you need to do Control, Shift, and Enter. Why it's not giving us the right way? Equal mult transpose way of with matrix, and then mu mult of variance covariance matrix, and then this one. The formula you entered contains error. If you want to insert the single quotation mark before your text. Where it is wrong. This one is variance covariance. No, we have to recheck it here. So E54. So I'm just pasting that formula here. So instead of C54, I have K4 and K6. So K4 and K6. And instead of E54, I have K18, K18 to M18. E54 to G56. Okay. So here I'm gonna add E54 okay. And then at the end I'm gonna use the same value. So let me figure out why it's not taking the same value. Yeah, so you see there was some problem in the formula, but this is the right formula. So at the end you need to just put after writing the formula you need to put Control CTRL plus Shift plus Enter. Then it will give you this one. Otherwise it won't give you the value. So now you got the portfolio. this one is randomly. Now I have to use the data solver for this. How to do that? What now we have to do? Remember, we have to minimize. So here you can see data. In Excel, you will also see data, and then you have to get to the data analysis and you get the solver. I'm using WP. So what's my stake here? I need to minimize what? I need to minimize variance, right? Which variance? So I need to minimize this portfolio variance, yeah, or this variance. So I42. I put solver. I have 5 minutes, so I just minimize the variance, which is I54 011. What is the condition? So here I add the condition. What is the condition? That my weight should be equal to 1, right? Let me see. Let me confirm so that there is no mistake. C57. Yeah. So here I get the solver. Here no, not this one. Here I get the solver, and I have add this one, which is K7, which should be equal to 1. So the sum of weight, it should be equal to 1. This I add, and next I have to add another constraint. What was the second constraint? Second constraint is about the returns. It's 41. Now what it means that my variance, my mean can be changed. So I put like the second constraint, which is add mean. What is my mean? Mean is this one. First one is mean, right? So this should be any number, and with a small change. Let's say 0.0004, right? Okay. Now I solve it. A problem solved, not specified. It's a minimize 011. It's the right thing. This one. Solve. Change 0.00002. Okay. So let's see. I have already done this here. So if you go solver, you can get this one. This one is a variance, C57, which is like this is equal. The sum should be equal to 1. So here, oh yes, we need to select the weight. Okay, we are almost done. So here 57 is this one, and we need to minimize solve must contain formula. So here it's this one. So solve. Now it get okay. So now we get this one, another weight. So first weight, I'm gonna just copy it and I'm gonna put it like first weight. We have different weight, W1, W2, W3. So first one, I will send you this Excel file so that you can, so 0.33, 0.34, 0.33. That's what I did. And after solver, we get this one. This also give us the same number. Then we need to solve again by using different numbers. So if we solve it, with 0.01, it gives us further. So what I will do, I will send you this Excel file so that you can have a look. I know the class is finished. That's why I told you with Excel, it may get some problem. But anyway, I'm sending you this Excel file so that you can have look into it. And that's, I have sent it. Okay. So this is about today. So next time we will, after the holidays, we will talk about the probabilities. So I wish you happy holidays and stay safe, stay healthy, and take care of yourself. I already